Hello guys, welcome to our YouTube channel once again. Welcome to Add Maths plus Maths. Today we will be discussing the proof of how did we come up with the derivatives of the three trigonometric functions sine x, cosine x, and tangent x using the first principles about limits. Okay, so first thing that we need to discuss is all about y is equal to sine x. So how did we come up with the derivative of y is equal to sine x? Remember, when we say first principle, you have a point P, okay, where the coordinates are x, y, okay, and when you transfer that point P, okay, and make movements on the graph of y equals to sine x, okay, there will be a point Q. Okay, when you transfer that, okay, let's say this is point Q already, there will be a small increment in x since there's a movement, and if there is small increment in x, when I say increment, increase, okay, when there is a small increase in the value of the x, then there will always be a small increase in the value of the y. Thus, point Q will be x plus increment of x, comma, y plus increment in y. Okay? If we are going to consider this point Q, then y equals sine x will become, okay, the y will become y plus increment of y. Then the x as the angle here, okay, will be x plus increment of x. Okay, so y plus increment of y is equal now to sine the angle x plus increment of x. Thus, okay, if we subtract y from both sides, it will become increment of y is equal to sine the angle x plus increment of x minus y. Okay, remember our goal here is to find out the increment of y over increment of x. Okay, why? Because if you want to look for the approximate value of the derivative of the function, you have to look for the ratio between the increment of y over increment of x. Okay, so we substitute sine x for y. So if we substitute sine x for y, this y will become sine x. Okay, sine the angle x plus increment of x minus sine x. Okay, and there is a rule in trigonometry that if you are subtracting two sines with different angles, okay, it will become 2 cosine A plus B. Those two angles will be A and B over 2, then sine A minus B over 2, since we are subtracting two sines with different angles. Okay, but remember over here, what is A is x plus increment of x, what is B is x. So if we substitute, it will become this one, because x plus increment of x plus x is 2x plus increment of x. Okay, and x plus increment of x minus x, it says sine A minus B over 2. So what will be left is increment of x over 2. Okay, so remember, it should be cosine and then sine. It's different from cosine A minus cosine B. Okay, next. Again, our goal is to find out increment of y over increment of x. So we need to divide everything by increment of x, which will now in turn be like this. Okay, since we are all multiplying this, so 2 over increment in x, okay, will be multiplied to the values a while ago. We will be using this one to prove out what is really the derivative of y is equal to sine x. Okay, let's go to the next slide. This one now will be the things that we are using. I just want to put 2 over increment of x at the end. Okay? And remember, if I want to change this multiplication to division, I am going to get the second factor. I'll take the reciprocal of that and I'll make this as division. Okay? There. So it means sine over increment of x over 2 divided by increment of x over 2. Okay? And remember guys, as q, okay, if I will bring back this q and get back and get back and go nearer to the p, okay, to the original point, x approaches, or the increment of x will approach and approach 0. Okay? So if the increment of x becomes 0, okay, there, if the increment of x becomes 0, then increment of x here will be 0 divided by 2 plus x is x. Okay? So this part, cosine of the angle x plus increment of x over 2 will just become cosine x. Next, how do we get the value of this part? Okay, I'll shade that so that you will understand. Okay, how do we get the value of this part? Okay, to find out the value of this part, okay, and get the value of dy over dx, you have to have a test, okay, on the increment of x as it approaches 0. And because we are using first principle, so first principle is all about limits, and limits is when, okay, a certain function or the certain increment goes nearer and nearer to 0. Okay, there. Next. So what is the value of that one that I shade? Let's try to put a table and test. So the increment of x in radian, let's say I'll start with 0.5. Okay? It is 0.9896. Let's go to 0.4. Okay? 0.3, 0.2. Please observe what is happening with the value of the one I shaded a while ago. Okay? It's increasing and increasing and increasing. Correct? Let's go to 0.1. Okay? Let's try to put 0.05. So 0.05 is almost 1 already. So what if it is 0.00001? Might be, if the value might be 1 already. Okay? But we cannot put in 0, because 0 will have a different thing already. As I'm saying, as it approaches 0, but it won't become 0. Okay? Remember, we are only dealing with limits. So we limit our answers. Okay? So the value of this one is approximately equivalent to 1. Because as it approaches 0, it will become 1. Okay? So if this is 1, the red, okay, the one I transform to red is 1, and the one I transform to blue is cosine x, the value of increment of y over increment of x is cosine x times 1, which is cosine x. Thus, it will give you a conclusion that if y is equal to sine x, where x is measured in radians, then the derivative of y in terms of x in this function, y equals sine x, is equivalent to cosine x. So remember this, because on the next lesson, I'll be using this one, okay, to solve problems about trigonometric functions or derivative of trigonometric functions. Next, let's move on to the second trigonometric function, which is y is equal to cosine x. Okay? Still, q is x plus increment of x, y plus increment of x. Thus, it will become y plus increment of y equals cosine the value of the angle x plus increment of x. If I will subtract both sides by y, it will be this one. And if I will change the value of the y to cosine x, it will be cosine x plus increment of x minus cosine x. Now, there is again a rule, okay, in trigonometry that says cosine a minus cosine b is equal to negative 2 sine a plus b over 2 sine a minus b over 2. Okay, so remember this. Okay. Next, let's change what is a and what is b. A is x plus increment of x. B is x. Okay, just change, you will get this one. You will find this. Because x plus increment of x plus x is 2x plus increment of x. And x plus increment of x minus x is equivalent to increment of x. Thus, if you divide by increment of x the whole equation, it will become this one. Negative 2 over increment of x, okay, times sine 2x plus increment of x of 2 over 2 times sine increment of x divided by 2. Okay? Next, we'll use that one to prove out again what is really the value or what is really the derivative of y in terms of x when y is equal to cosine x. Okay, so let's move 2 over increment of x at the end. We'll do the same thing just like what we did a while ago. I'll get the reciprocal of 2 over increment of x and make this division. So you now notice that the blue one was proven already a while ago. If increment of x approaches 0, okay, it will become suddenly 1. Okay, so this equivalent of this blue lettered expression will be equivalent to 1. And this part, since x approaches 0, okay, or increment of x approaches 0, so 0 divided by 2 plus x is just x. So dy over dx will be negative sine x, because 1 times negative sine x is negative sine x. So dy over dx of, or the derivative of y in terms of x, if y is equal to cosine x, is negative sine x. Next, how about if I want to differentiate y is equal to sine x over cosine x with respect to x? Remember, this is quotient rule. What is the derivative of sine x? Cosine x. What is the derivative of cosine x? Negative sine x. And later on, you will have a conclusion that sine x over cosine x, is, what is the equivalent value of this, or what is the equivalent trigonometric function of this one? It's tangent x. So basically, what we are looking for now is the derivative of tangent x. Okay? So how do we look for that? Let's represent sine x as the u, represent cosine x as the v. Okay, du is cosine x, dv is negative sine x from our previous discussion. Okay? And remember, quotient rule says v du minus u dv divided by v squared. Okay? So let's just plug in. We'll have this. Remember, cosine x times cosine x is cosine squared x. Sine x, negative sine x times negative sine x is plus sine squared x. Cosine x squared is cosine squared x. There. And notice that cosine squared x plus sine squared x is what value? The value of that is 1. From your trigonometric identities, that says 1 is equivalent to sine squared x plus cosine squared x. Okay, so this one will be 1. over cosine squared x. And 1 over cosine is secant, but there is a square. So it will become secant squared x. Thus, you will now say that dy over dx is equal to secant squared x. And you will be telling me now that if y is equal to tangent x, because tangent x is basically sine x over cosine x. Okay? Where x is measured in radians, then dy over dx when y is equal to tangent x is equivalent to secant squared x. So I'll repeat and summarize everything. If you have sine x, get the derivative of that, or finding the derivative of that, it is always cosine x, or the derivative of sine x is cosine x. The derivative of cosine x is negative sine x, and the derivative of tangent x is secant squared x. Okay? Thank you for watching this video. I hope I was able to help you understand how did we come up with the derivatives or differentiation of the three trigonometric functions. Thank you and God bless.